Yes, hello, am I audible? Yes, Afra, am I audible?
Yes, ma'am.
Okay, just 1 minute. Okay, Afra, so currently in this batch which you have joined, the chapter area related to circle is going on. Okay, Rida, till the other students join, I'm just giving a very quick revision to Afra, okay? Yes, you can stay here. We can have a quick revision. Areas related to circles. Yeah, Afra, can you just tell me one thing? Please unmute your mic. Okay, are you already done with your half yearly examination?
No, ma'am. Like I have half yearly examination coming week,
Coming week. Okay, so when is your maths exam?
Thursday.
Thursday. Okay, coming Thursday. So, like, have you done the chapters on your own?
No, like some chapters are left.
Okay, how many chapters are coming? First of all, tell me that.
8 chapters.
Can you name them?
Real numbers, polynomials, quadratic equations, triangles, coordinate geometry, and trigonometry.
Okay, just 1 minute. Real number, polynomial, then quadratic equations, and
Triangles,
okay, and
coordinate geometry,
coordinate geometry, then
trigonometry.
trigonometry. Okay, okay. So in this school, all the chapters are over, right?
Yeah.
And in how many chapters you're confident right now because you have a coming exam?
Trigonometry, coordinate geometry, and triangles.
Okay. So real number, polynomial, and quadratic equation, you are not confident, right?
Yeah.
Okay. So Afra, I'll do one thing first of all.
Okay.
First of all, I'll provide you the recordings of these 3 chapters, which we have already completed in this batch because now you also understand this thing, right? It's not possible to cover all the chapters in few days. It takes
Yeah.
time. So at least you can listen to the recordings whenever you get time. And for currently, like for this examination, at least you will be able to prepare something. And then today, actually, it's a running batch, and the chapter is actually some students are absent today. So that is why I'm not proceeding with the chapter.
Okay.
Rida, tell me one thing.
Yes, ma'am.
Can we revise polynomials today?
Okay.
Okay. Yeah, okay. So I'm starting with polynomials. Just 1 minute. Let me open my book. Just 1 minute. I'm just opening my PDF of polynomials. Hmm. I hope my screen is visible, right?
Yes, ma'am.
Okay, polynomials. Uh, First of all, what is polynomial? Let us try to understand, right? Mm, any expression, for example, I'm writing this 2x square, right? This is an algebraic expression. Or I write this 2x square plus 3x, okay? I write 3x cube plus 6, okay? And also I write only 6, let's say, right? So all these are called polynomials. Poly means many, right? So it has only one variable, which is x. So it's a polynomial in one variable. So again, they all are polynomial in one variable. And if I have something like that, so this is a polynomial in two variable, right? So the important thing in polynomial is first, which is called degree of polynomial. Degree of polynomial, which is actually the highest power of variable. Now, what is a variable? Mm, for example, this is a polynomial 5x cube minus 3x square plus x minus under root 3. Let's say this is a polynomial, right? Now, what is the highest power of x here? Yes, Afra. So you have to unmute your mic. Rida, you can also respond. What is the highest power of x here?
3.
3. Okay. So it's a polynomial of degree 3, right? Now, variable is this. These all are numbers, okay? They are called coefficients. And this is called variable. It can be x, it can be r, it can be t, a, b, y, whatever. So, like it can take up different values. So therefore, it's called variable. And because this polynomial is in variable x, so we denote it by px, right? If it was y, so we denote by py and like that. For example, there's another polynomial which is in u. So I denote by pu. For example, this 9u6, okay, minus 4 by 5 u4 and minus 2u minus 6. What is the highest power of u here?
6.
6. So this is a polynomial of degree 6. And now please note one thing. These coefficients, as you can see, this is under root 3. So this is not just under root 3. It's basically under root 3 into x to the power 0, right? When nothing is written, so that means it's x to the power 0, which is 1. So we don't write it. It's understood. And this is 4 by 5. And yeah, so you can see the coefficients can be any kind of number. It can be a rational number. It can be a irrational number. As you can see, this is an irrational number. It can be a fraction. It can be negative. It can be positive. So it's going to be a real number. Understood? Only the coefficient. It is a real number. Real means it can be rational also and it can be irrational also. This combined set is called real numbers. Okay. Okay. Now, now you come to variable. Now variable should have power of whole number only. Please remember, whole number only means x power 0 to 1, 2, 3, and so on up to infinity. So they are all whole numbers. So if the power of x is, for example, x to the power 1 by 2, so it will not be a polynomial. Understood? If in some expression you have this kind of power, it's not a polynomial. It has to be whole numbers only. Is that clear?
Yes, ma'am.
Okay. So if I talk of degree, so degree 1 polynomial, they are called as linear polynomial, right? Degree 1 means linear. So for example, degree 1, I can write 2x minus 3. Okay. And I can write k plus under root 2. I can write 4 by 5 m minus 1. So they are all degree 1 polynomial. They are called linear polynomials. Is that clear?
Yes, ma'am.
Then we have degree 2 polynomial, which are called quadratic polynomials. Right? So degree 2, you can give some example. 2x square minus 3x plus 4, it's a degree 2, right? Highest power of x is 2. Another can be under root 5 k square minus 2 by 3k. This is again a quadratic polynomial. Okay. Hmm. Yeah, like here itself, you can write the general form also. Let us write the general form of a degree 1 polynomial. So it looks like this, ax plus b, right? If you find this kind of polynomial, it's a degree 1, it's a linear. So there's a condition a cannot be equal to 0. Why? Because a is 0, that means the first term is 0. You are only left with only constant b. So the variable is actually gone, right? So this coefficient of x cannot be 0. So this is a general form of a linear polynomial. Now you write general form of a quadratic polynomial. So any polynomial of this form, ax square plus bx and plus c. Again, a cannot be equal to 0. See, b can be 0, right? B can be 0. So you are left with only ax square plus c. Again, it's a quadratic polynomial because the highest power is 2, right? But if the coefficient of x square is 0, that means the x square term is gone. You are only left with bx plus c, which is not a quadratic. Is that clear?
Yes, ma'am.
Yeah. So a cannot be equal to 0. And then degree 3, uh, it's called a cubic polynomial, right? You can give some example again. For example, under root 5x cube, that's it, right? And 2 minus k square plus k cube, it's again a cubic polynomial. Okay, you can write general form. So general form will be ax cube, right? bx square plus cx plus d. Again, a cannot be equal to 0. Other terms can be 0. For example, in this one, only a is there. B, C, D, all are 0, right? Okay. So I think now you're familiar with the degree of a polynomial.
Yes, ma'am.
Okay. And like combined, you can write A, B, C, D. They are all real numbers. Okay. So just one time you can write it. Real numbers, that means rational plus irrational. So it can be any kind of number. Now, so this is the first thing in this chapter, which is degree of polynomial. Now, the second thing which you need to know is value of a polynomial. Now, what is value of a polynomial? Let's take a polynomial in x, right? For example, simple one, 2x square plus 3x minus 4. Let's say this is a polynomial in x. So x is a variable. That means x can take up different values. You can take x is equal to 0, x is equal to 1, 2, 3, 4, 100, 1000, whatever you wish. So let me take 4, x is equal to, let's take 1, right? For x is equal to 1. How much is my p? Now I'll write 1 because my x is 1. So wherever you have x, put 1. So 2 into 1 square plus 3 into 1 minus 4. So you solve it. So this is 2 into 1 plus 3 minus 4. So this is 2 plus 3 minus 4, and that is 5 minus 4. 5 minus 4 is 1. So this is called the value of polynomial, right? Value of px at x is equal to 1. Is that clear?
Yes, ma'am.
So this is how you find values. Okay. Now there is a third thing in this chapter which is important, which is called zero of a polynomial. So value you can find for positive x also, for negative x also, right? You can take x is equal to -6 and you can find the value p minus 6, right? So whatever you get, that will be the value of polynomial at that particular x. Now zero of a polynomial, what is it? Mm, okay, now you are finding the values, correct? Just try to understand. For example, you are finding the value of polynomial at x is equal to 1, right? You are getting something. Okay, then you are finding at x is equal to -2, you're getting some number. Okay, now you're finding at x is equal to 3 and you are getting 0, right? So this 3 will be called the zero of this polynomial. Understood? Like 0 is actually that value of x at which the value of the polynomial becomes 0. Is that clear?
Yes, ma'am.
Okay. Mm, so you can write that if p at k, k is some value of x, is equal to 0. Let me give you one px first of all. Okay, I'll give you example later. So if pk is equal to 0, then k is said to be the zero of the polynomial. Is that understood, Arfa? Arfa or Afra? Sorry. It's Afra. Okay. Rida, is this understood?
Yes, ma'am.
Okay. See, you have any polynomial and at some particular value, if the value of the polynomial is becoming 0, then that k is called the zero of the polynomial, right? For example, I give you example. Let's say I have a polynomial in x, which is x square minus 3x minus 4, right? So you can check its values at different x. Let me check this at p is equal to -1. What will you get? So -1 whole square minus 3 into -1 minus 4, right? So this is minus minus becomes plus, so that is only 1. Minus minus plus, so plus 3 minus 4, right? So this is 4 minus 4, which is 0. So what does it imply? That x is equal to -1 is the 0 of px. Is that understood?
Yes.
Oh. Now, what is the geometric meaning of 0? So this is again important. See, now you have understood the algebraic meaning of 0, right, Afra? Algebraic meaning is that it is that value of x at which the value of the polynomial becomes 0. So algebraically, we understand what is 0 now. Okay. It is 0, or you can call it root also, because 0 is, very confusing term. So sometimes I call it root also. There's no problem. Okay. So at any value of x, if the value of the polynomial is becoming 0, so that x is actually the root of this polynomial. Okay. Now, what does it mean geometrically? Mm, see, for this, to understand this, you need a graph paper, but roughly I'm just doing it now for your understanding. I think it's visible on the screen. So I take a polynomial. Let us start. Px is equal to x plus 2. Very simple polynomial I'm taking. Okay. So algebraically, let us find out its 0. Let us find out algebraically. Right? I want to find the 0 of this polynomial. Now, I know that, 0 is that value at which my px is 0, right? At which my polynomial is 0. So for 0, set px is equal to 0, right? That means if the value of the polynomial is coming out to be 0, that means that particular value of x is the 0. Okay. So that means my x plus 2 is equal to 0, and that gives me x is equal to minus 2. So algebraically, my 0 is minus 2. Is that understood, Afra?
No.
No. Okay. Now pay attention. See, what did I tell you? What is 0? For example, uh, okay, then x plus 2 is my polynomial, right? I can give different values of x. So I give x is equal to 1, let's say. So I get 1 plus 2, which is 3, which is not equal to 0, right? Then I take x is equal to, let's say, 0. So I get 0 plus 2, which is 2, which is again not 0. If I take x is equal to minus 1, so I get minus 1 plus 2, which is plus 1, not 0. And if I take x is equal to minus 2, so I get minus 2 plus 2, which is 0. Now I'm getting 0, right?
Yeah.
That means this is 0 of this polynomial. Understand? So this
Yes.
x is equal to minus 2 is actually the 0 of this polynomial. Okay. So if you are given a polynomial, 0 means, see, 0 means your polynomial is at this 0, your value of polynomial is 0, right? You mean at 0, what is happening at 0? 0 means the root, right? At the root, your value of the polynomial is 0. That we know, right? We have understood that. Yes, Afra?
Yes, ma'am.
This is the meaning of 0. Try to understand. Okay, just I'm using root in terms of 0. I think it's confusing, right? Okay. So what is happening at this root? At this root, the polynomial value of the polynomial is 0, correct? As you can see here, minus 2 is giving me 0, right? That means x is equal to minus 2 is the root of this polynomial. Is that clear?
Yes, ma'am.
Okay. So you can do it this way also. If the polynomial is given, let's say x plus 2, and you want to find its root. So for root, so I know that if I want to find the root, so root will be that value at which my polynomial is going to be 0. Correct? All these other values are not root. Only this value is root at which my polynomial is 0. So I just simply equate my polynomial to 0. And that will be the root. That particular value of x. Is that understood?
Yes.
See, this is an important concept. Try to understand this. So this is the definition of root. That if at some value of x, your polynomial is 0, that is the root. Okay. So if you want to find the root, you simply equate your polynomial to 0 and get it. So px is equal to 0. That means x plus 2 is equal to 0 and x is equal to minus 2. That means this is the value of x at which your px was 0. Right? So algebraically, this is how we find the root. Just equate your polynomial to 0 and get the value of x. I hope it's understood now.
Yes.
Okay. So algebraically, we know x is equal to -2 is the root. Okay. Now let us learn how to plot it on a graph paper. So this was your polynomial. Px is equal to x plus 2, right? So if I choose some axis, like very roughly I'm choosing, let's say this is my y-axis and this is my x-axis. Right? Because x is a variable, it can take up different values. So this is my x. So I'll give different values of x and I'll see the corresponding values of px. So this is my polynomial here on this axis, or you can call it y also. Y is equal to px, y-axis or px. Okay. So x and your px. Now you start giving different values of x and get the corresponding value of px. So I give value 0 to x. So what my px becomes? So px is 0 plus 2, which is 2, right? So I get 2. Then I give some other value. I give 1. So I get, p1, I get 1 plus 2, which is 3. So I get my polynomial value 3, right? And let's say I give -1. So -1 plus 2, that will give me +1. I get -2. So -2 plus 2, that give me 0. Now the 4 values are enough. Yes, Shri Harsha, can you hear me?
Yes, ma'am.
See, actually you people were not there in the class, so I thought you will not join. So I'm just giving a revision to a new student, a revision of polynomials.
Okay, ma'am.
So you can also attend it if you wish. So we are doing revision of polynomials.
Okay, ma'am.
So let us plot it, Afra. So when x is 0, so this is 0, 1, 2, 3, 4, 5, 6, 7, right? -1, -2, -3, -4, and like that. 1, 2, 3, 4, -1, -2, -3, like that. Okay. So let us put it here. First, when x is 0, px is 2, right? So when x is 0, your px is 2. That means this point. So name it. This is 0 and 2. See, this naming you will do in coordinate geometry, but I'm just writing it, okay? Or if you don't want to write, just don't write, okay? Because in this chapter, you have not done how to name it. But if you want, you can. Now, second, x is 1, px is 3. So when x is 1, px is 3. That means this point. X is 1, px is 3. Next, x is -1, px is 1. So this is -1 and this is 1, right? Now when x is -2, px is 0. So that means this point x is -2, px is 0. So you can see the 4 points. If I want to join it, I can join them with a line. Oh, sorry, it's a bit... Yes, can you see that, Afra?
Yes, ma'am.
Okay. So algebraically, I know x is equal to -2 was a 0, right? Was a root or was a 0. Now in the graph, where is x is equal to -2? See, this line is actually not drawn properly. So there's a issue. Let me just draw it with the, roughly with a pen. I think that will make it easy to understand. Yeah, so this is the line basically, right? You can make it with the help of a scale. Now, can you just locate x is equal to -2 in this diagram? So here is my x is equal to -2, right? Right? See, I already know that x is equal to -2 is a root of this polynomial. So in the graph, I can see that root is that value of x at which it is touching the x-axis. Right? Okay, if you want to write for your understanding, you can write like we can see that -2 is the value of x at which the line touches the x-axis. Right?
Yes.
Okay, and we already know that it is a 0. See, this is like for your understanding, I'm telling you. So we can see that -2 is the value of x at which the line is touching the x-axis, and algebraically we already know that it is a 0. So how can we define 0 now? So 0 of px is nothing but x coordinate, right? X coordinate, you can underline x coordinate of the point at which the line at which the line cut the or touches, you can say touches the x-axis. I hope it's understood.
Yes.
So if only graph is given to you, the polynomial is not given, and we ask you to find the 0. So simply by looking at the graph, you can tell me which is the 0 of the polynomial. So you will see where the graph is actually cutting the x-axis or touching the x-axis. That particular value of x is going to be the 0 of the polynomial. Okay. For example, if I have something like this, roughly, at how many points it is touching the x-axis, Afra? 2 points, 1 and 2, right?
Yeah.
So this has you can say two zeros. This particular polynomial will have two zeros. Okay. Mm. So if you have a linear polynomial, so the polynomial I have just drawn was a linear, right? Px is equal to x plus 2. The highest power of x is 1. So it's a linear. And we have seen that we have got a line. So that is why it's called a linear, because its graph gives you a line. So therefore it's called linear. Okay. So just very quickly, I'm telling you. So if you have, for example, quadratic polynomial, you don't have to draw it, just try to understand. And if you plot a quadratic polynomial, so you get something like this. Either you get a figure like this, right? Or you can get something like this. So these are called parabola. So you get a parabolic figure, parabola in this case. It's not a line, it's a parabola. Okay. Let us come to first exercise just very quickly. See, this is the first exercise, Afra. Now, polynomial is not given, only the graph is given. Okay. And you have to tell me how many, for some, the graph of y is equal to px are given below for some polynomial px. Okay. Find the number of 0. Now, in the first graph, how many zeros are there, Afra?
No, 0.
There is no 0. Why? Why there is no 0? See, because the line is not touching the x-axis, right? This is the line of, sorry, see, this is your line of the polynomial and it's nowhere touching the x-axis, so there's no 0. Now second diagram, so I can see that at one point here, at this point, it is crossing or touching the x-axis, so it has 1 0, right? Now third one, so it is touching here, right? It is touching here and it is again touching here, so it will have 3 zeros. Now what about this fourth one?
2.
2 0. Okay. Now next.
4.
4. Okay. Then next.
3.
3. Okay. So only x-axis you have to see, right? So 1, 2, and 3. Okay. So I think the geometric meaning of 0 you have understood, right?
Yes.
Okay. Now, so exercise 1 you can do now. Now the second is basically the relationship. The next exercise is about the relationship between 0 and the coefficient. Okay. Now, how are they related? Relationship between zeros and coefficient of a polynomial. Mm, I think I'm not going to derive it. You can just simply write it down. So if you have a linear polynomial, first of all, linear. Okay. Which looks like this, ax plus b, right? So it's 0. What will be its 0? So what we do for 0, we equate px is equal to 0. That means ax plus b is equal to 0. So x is equal to minus b by a. So 0 is minus b by a, simple. See, you don't have to remember it, I think. Don't write it, otherwise you'll get confused. Just leave it. You know the concept that for 0, you just equate your polynomial to 0 and get it. Come to quadratic now. If you have ax square plus bx and plus c, right? It's a quadratic polynomial. See, I don't want to give you too much of formula to remember. Just try to understand the concept. That's it. So it's a quadratic polynomial. And if alpha and beta are zeros, right? Then what is the relationship? Then the sum of the 0, alpha plus beta, is equal to minus of b upon a. This you have to remember. And the product of the 0 is c upon a. This you have to remember. Right? Okay. And then if you know alpha and beta, then any quadratic polynomial can be formed as. So p of x will be k into x square minus alpha plus beta into x and plus alpha beta, right? So x square minus, this is sum of roots, sum of 0 into x plus product of 0. And uh, k is any integer, so it can take up values 0, 1, 2, 3, and like that. Okay, Afra, any questions so far? Any confusion? I can't hear you. Rida, any confusion here so far? Okay, anyway, if you don't have any question, let us do exercise now. Yes, Afra, can I hear you?
Yes, ma'am.
Okay, so let us come to exercise 2.2. Find the zeros of the following quadratic polynomial and verify the relationship between the zero and the coefficient. Okay, so some questions I'm going to solve. For example, x square minus 2x minus 8. So first thing is you have to find the zero, right? So please remember for 0, set px is equal to 0. This is your px. Simple. So x square minus 2x minus 8 is equal to 0. And solve it, get your value of x. Now this is a quadratic polynomial. How to solve it? So there's a method of splitting of the middle term, right? Do you know that, Afra, sorry. Okay, let us do it. What is splitting of middle term? Now here the coefficient is 1, right? So you multiply 1 by this last coefficient 8. So what you get? 1 into 8 is 8. Then you do prime factorization of this 8. So 2 into 2, sorry, 2 into 4, 2 into 2, and 2 into 1. Right? Now you have to make some pairs so that on adding you get minus 2. Okay? So if I take 4 and 2, so and I want to get minus of 2. So how can I write it? Mm, I can write minus 4 and plus 2. This is going to give me minus 2, right, Afra?
Yes.
So I'll write it like this. So x square, then minus of 4x and plus of 2x. This way I can write it. And minus of x is equal to minus 8, 0. Now from first two terms, take x common. So you have x minus 4, right? Next two terms, you can take 2 common. So you have x minus of 8 is equal to 0. Then, oh, sorry, x minus 4 is equal to 0. Then x minus 4 is there in both the terms. So take it and you get x plus 2, which is equal to 0, right? So, uh, Now we have split the quadratic polynomial into two linear polynomials. Okay, product of two linear polynomials. So one by one, first we take this in the denominator, and 0 divided by any number gives you 0. So that means only x plus 2 is equal to 0 will remain. So x plus 2 is equal to 0. And second time we take x plus 2 in the denominator. So only x minus 4 is equal to 0 remains. So two things can happen here. So x is equal to minus 2, and here x is equal to 4. So I get two values, minus 2 and 4. Is that okay?
Yes.
Okay. So these are the zeros. So I have found the 0. So zeros are minus 2 and 4. Now you have to verify the relationship between the 0 and the coefficient. Okay. So we do verification now. So basically what should happen here? Now your alpha is minus 2 and your beta is 4, right? Now we already know that alpha plus beta is equal to minus of b by a. Is that okay? And we know that alpha beta is c by a. This we know. We have to verify this thing. Okay. Right. Anyway, write your polynomial. So what was your polynomial? It was, can you tell me what was that? X square minus 2x and minus 8. So x square minus of 2x minus 8. Now what is a here? A is 1, coefficient of x square, right? B is minus 2 and c is minus of 8. Is that okay?
Yes.
Okay, so now you check how much is your sum, or how much is alpha plus beta. So your alpha is minus 2 and your beta is 4. So this is giving you 2 only, right? And you have to bring it to this form. So how can you write it? Uh, can I write this 2 like this? Minus into minus 2. Is there any problem? Yes, because minus multiplied by minus is going to become plus. And then in the division, I can put 1 because there is nothing, so I can put 1. Why I'm doing this? Because my b is equal to minus 2. I want to introduce something here, right? Now this bracket is your b. So you get minus of b, and then 1 is your a. You get minus b by a. So this is verified. Okay.
Okay.
Now alpha and beta. So my alpha is minus of 2 and your beta is 4. So I'm getting minus of 8, right? So I should get it in this form, c by a. So I can write minus 8 upon 1. When there is nothing, I can write 1. Now minus 8 is your c and 1 is your a. So this is again c by a. So it is verified. Right? So can you just try other parts yourself, Afra?
Okay.
Now I'll do one thing. I'll ask the Learnivio office to provide you the recording of this chapter, polynomial, where I have already solved all the questions. So you can just go through them. Okay. Now
Okay,
second
ma'am.
now second question, one part I'm doing, then other you can try yourself. So find a quadratic polynomial. So this time polynomial is not given, you have to find it. Uh, each with the given numbers and the sum and the product of 0 respectively. So what is actually given in this question? sum of 0, that means alpha plus beta is already given, and uh, yeah, okay, and alpha beta is already given in this question, correct? Okay, so if I talk of first part here, so your alpha plus beta is given, which is 1 by 4, right? And your alpha beta is given, which is minus of 1. Okay, so required polynomial is, so as I told you, x square minus alpha plus beta into x and plus alpha beta. But there's a k multiplied outside. Okay. See, k can take up different values. You can give it value 1, you can give it value 2. All these will be your required polynomials. Okay. So if you take k is equal to 1, that means you don't write anything. So this is one of the required polynomial. It is not the ultimate answer of this question. Understand, Afra?
Yes.
This can have, the required polynomial can be infinite in this case. K can take up different values. Okay, so this is k into x square minus, now your alpha plus beta is 1 by 4 into x, plus your alpha beta is minus 1, and please use brackets always, otherwise you will make mistakes. So k into x square minus 1 by 4x and plus minus minus of 1, right? So if you want, you can take LCM. This is like, okay, you take LCM. So LCM will be 4, right? So this becomes 4x square minus of x and minus of 4. This is, now you give some value of k. So k is equal to 1 if you want, if you are taking. So your px is this, which is like 1 by 4 into 4x square minus x minus 4. This is also a correct answer. Or you can take k is equal to 4 directly. So your px will become 4 into 4x square minus x minus 4 and divided by 4. So this 4 cancels out, right? And you get this 4x square minus x minus 4, which is actually the answer given at the back of NCERT. So this is not the only one possible answer. Okay. I mean, this is one of the possible answer. It's not the ultimate answer. This is also a correct answer. Or you can take k is equal to 2. You can take k is equal to 100. Whatever you can take, you or whatever you want, you can take it. All answers are correct. Yeah, Shri Harsha. Can you
Yes,
hear
ma'am.
me? Yeah. Shri Harsha, now you please note. So on Tuesday, I'm going to take a test. Okay.
Okay, ma'am. Of circles.
Yeah, I'm just writing. No, no. Sorry. Tuesday, there will be a test. Circles we have not done. Area related to circles.
Okay, ma'am.
Mm, okay. Exercise 12.2. Up to exercise 12.2, I'll give. So I'll not give the questions which we have not done so far, but some simple questions I'll give you. Okay.
Okay, ma'am.
Okay. So Tuesday, please note. Uh, Yes, Afra, so you have to leave now. Harsha, you too, because I have my next class. So, Afra, would you like to say something? Okay, then, Harsha, you can leave.
Thank you, ma'am.